So one of the main categories of synthesis techniques involves filtering. It's also commonly found in special effects. And if I look at filters, I again try to find three different parameters that I could map out the many different filtering techniques based on. So again, I map them out in terms of number, in terms of complexity along the z-axis, and then I thought maybe it would be interesting to map it out in terms of bandwidth or Q along the y-axis here. So if I look at starting off down here with some simple filters, I could have a simple low-pass filter, a high-pass filter, and a band-pass filter, and also say a band reject filter. So those are several different types of filters. Then I could have each of these with resonance. So I could have a resonant high pass or a resonant low pass filter over here. As I move out in this direction, eventually I come out to be self-oscillating, and that by itself is sort of just a simple, produces a simple sine wave, or may have some other characteristics of the original waveform built into it depending on what it is. So a very sharp peak here generating a self-oscillating filter. Then if we go well, what other kinds of filters are there? Well, a parametric filter may have more than one different peaks and valleys in it, and so that would increase in number. It may be, it's typically a little more, has a little bit tighter bandwidth, and may actually be a little bit higher up. So this one is slightly increased in complexity. If we go out here with lots of simple filters, a graphic equalizer might be somewhere around here, where the bandwidth is inherently smaller because you have lots of different filters just because of the nature of the graphic equalizer. But the and so it's out here, but they're very simple, so it doesn't have much complexity to it. Now if we look at something like a vocoder, so let's look at a vocoder, that would have a lot of complexity. Let's see, it has a large number of filters, and they're somewhat low in, or have a pretty small, pretty large Q, pretty small bandwidth. So vocoder is going to come out somewhere around here. And then if we look at some other tools, let's look at formant filtering. So that has a relatively fair amount of complexity to it. Because you're applying different vocal formants to the signal. It has a moderate number of different filters going on at once, and it has a moderate amount of complexity. They are somewhat peaky, so this has to move over here along the y-axis a little bit. I go from here and bring it out that way. Okay, and so that's a formant filter. Let's see what else we got here. We could do a Fourier transform that has a large number. You can do a lot. They can be quite complex. I would say a regular one is moderately complex. By the time you get to a short-term Fourier transform, or a short-time Fourier transform, they're getting pretty complicated, and large number of different frequencies can be analyzed. Spectral filtering is out here, pretty complicated with Fourier transform. Let's see, if I take these self-oscillating waveforms and just increase along the number axis, I get back to sort of an additive synthesis again. So here I'm coming back to something that started out as in the oscillator region, now it's showing up again in the filter region. So I can take several self-oscillating filters and create additive synthesis out of that. And then there could be distortions that occur. So when you look at distortion or clipping, that could be considered a type of filtering, and that might be let's see. So let's see. What makes something like a TB303 or a Minimoog filter sound interesting is the distortion. So this is a simple filter. It's a low pass resonant filter, so that puts it somewhere around here on this axis. But due to the distortion, you could think of it either as it's adding in complexity, so this would be a distorted filter. Or you could think of it as having more overtones, and so there's actually a large number of overtones produced when this is doing it, and so it could be having a larger or a greater number of filters applied to the same signal and then combined again to form that distortion characteristic of a distorted filter. Okay, now what I look for once I have all of my different types of known filters in here, and a comb filter, I might put that over here somewhere. It's fairly simple, but has a little bit of complexity, doesn't really have any sort of bandwidth to it at all, and although you can increase the feedback to sort of create some bandwidth, so that's sort of in this range. Anyway, once I've mapped out a bunch of different types of filters, I try to look for places where I don't see too much activity. Now one of the things, and maybe there's a reason for that, so if I look up here at this point on the graph, there's not really too much going on over here, and so this would be a single simple filter, or a single filter with wide bandwidth or even narrow bandwidth that has a great deal of complexity to it. And so is there a way to think of something like that? I can't think of anything. So here's one with lots of so anywhere along this axis I don't really have anything that I can think of that sort of fits into that category. Maybe even just a little bit this way would be worthwhile for fitting into that category. Also, this point out here where we have the combination of complexity, large number, and very short or very long things, this one is often not used, but there's sometimes a good reason that there's nothing much in that category either. Okay, so that's a general approach, is to take whatever technology you have, first of all do a mind map to try to think of all the possible types of examples of that technology that you can come up with, search it out, find out what they are, then try to divide them, each of the parameters associated with that technology into 3 different continuous variables, and then map out the technology along the variables and look for gaps. Where are there places that things are missing in this mapping into this space? Okay, so that's the main idea behind this. Thank you for listening.